What is diode and how it works? A diode is a two-terminal semiconductor device that allows current to flow in only one direction. It acts as a one-way valve for electric current. When a positive voltage is applied to the anode terminal and a negative voltage to the cathode terminal, the diode allows current to flow through it. However, if the polarity is reversed and a positive voltage is applied to the cathode and a negative voltage to the anode, the diode blocks the current flow. Diodes are commonly used in various electronic circuits for rectification, voltage regulation, signal demodulation, and other applications. There are several types of diodes, each designed for specific purposes. Here are some common types of diodes. Rectifier diodes are a type of semiconductor diode specifically designed for rectification purposes. Their primary function is to convert alternating current, AC, into direct current, DC, by allowing current flow in one direction while blocking it in the opposite direction. They are widely used in power supply circuits and various electronic devices to convert AC voltage to DC voltage. There are two main types of rectifier diodes. Half-wave rectifier diode. In a half-wave rectifier circuit, a single diode is used to rectify the AC input voltage. The diode allows current flow only during the positive half-cycle of the input AC waveform, while during the negative half-cycle, it blocks the current. As a result, only the positive portion of the AC waveform is passed through, and the negative portion is removed, creating a pulsating DC output. Full-wave rectifier diode. A full-wave rectifier circuit uses four rectifier diodes arranged in a bridge configuration, commonly known as a bridge rectifier. This arrangement allows both the positive and negative halves of the AC input waveform to be rectified, resulting in a more constant and smoother DC output compared to a half-wave rectifier. The full-wave rectifier is more efficient and commonly used in power supplies. Rectifier diodes come in various voltage and current ratings, depending on the application's requirements. They are available in different packages, such as axial lead packages for through-hole mounting and surface mount packages for SMD, surface mount device, applications. It's important to note that while rectifier diodes are effective at converting AC to DC, the resulting output is still a pulsating DC voltage. In many applications, additional filtering capacitors and voltage regulation circuits are used to smoothen the output and provide a stable DC voltage suitable for powering electronic devices. A half-wave rectifier diode is a simple semiconductor device used to convert alternating current, AC, to direct current, DC, by allowing the flow of current in only one direction. It is one of the basic rectification circuits used in power supplies and other applications where a single diode is sufficient to convert the AC voltage to pulsating DC. The working principle of a half-wave rectifier diode is as follows. Rectification: during the positive half-cycle of the AC input voltage, the diode is forward biased, allowing current to flow through it. This means the diode conducts and allows the positive half of the AC waveform to pass through unchanged. Blocking: during the negative half-cycle of the AC input voltage, the diode becomes reverse biased, effectively blocking current flow. In this state, the diode acts as an open circuit, preventing the negative half of the AC waveform from reaching the output. The output of the half-wave rectifier is a pulsating DC waveform. It only contains the positive portion of the AC input voltage, while the negative portion is completely removed. The output voltage is not constant but follows the shape of the positive half of the input AC waveform. The half-wave rectifier has a few disadvantages that limit its practical use in many applications. Low efficiency: since only half of the AC input voltage is used in the output, the efficiency of the half-wave rectifier is relatively low. Pulsating output: the output of the half-wave rectifier is not smooth, which can be problematic in some electronic applications. Additional filtering is required to obtain a more stable DC voltage. Due to its simplicity, the half-wave rectifier is sometimes used in applications where a low-cost solution is acceptable, and the disadvantages mentioned above are not critical. However, for most practical purposes, a full-wave rectifier, using a bridge rectifier circuit, is preferred, as it provides a more stable and efficient DC output by utilizing both halves of the AC waveform. A full-wave rectifier diode is a semiconductor device used to convert alternating current, AC, to direct current, DC, by rectifying both halves of the AC input waveform. It is a more efficient and commonly used rectification circuit compared to the half-wave rectifier, as it utilizes both positive and negative cycles of the AC input voltage. The most common configuration for a full-wave rectifier diode circuit is the bridge rectifier, which consists of 4 diodes arranged in a bridge configuration. The working principle of a full-wave rectifier diode circuit is as follows. Rectification: during the positive half-cycle of the AC input voltage, 2 diodes, D1 and D2, are forward biased, allowing current to flow through them. This means the diodes conduct and allow the positive half of the AC waveform to pass through unchanged. Blocking: during the negative half-cycle of the AC input voltage, the other 2 diodes, D3 and D4, become forward biased, and the previously conducting diodes, D1 and D2, become reverse biased. This effectively blocks current flow through the diodes that were conducting during the positive half-cycle. In this state, the diodes act as open circuits, preventing the negative half of the AC waveform from reaching the output. The output of the full-wave rectifier is a pulsating DC waveform. It contains both the positive and negative portions of the AC input voltage. The full-wave rectifier provides a more constant and smoother DC output compared to the half-wave rectifier. To obtain a more stable DC voltage, additional filtering capacitors and sometimes voltage regulation circuits are used in conjunction with the full-wave rectifier. The filtering capacitors smooth out the pulsating DC waveform, reducing the ripple and providing a more steady DC output voltage suitable for powering electronic devices. Advantages of the full-wave rectifier diode circuit, bridge rectifier, over the half-wave rectifier include: higher efficiency: the full-wave rectifier utilizes both halves of the AC waveform, resulting in higher efficiency compared to the half-wave rectifier. Smoother output: since both positive and negative halves of the AC input are rectified, the output has less ripple and is smoother, requiring less filtering. Due to its efficiency and smoother output, the full-wave rectifier diode circuit is widely used in power supplies and various electronic devices where a steady DC voltage is required.